In this video, I will be explaining the representation of functions as power series. So basically, this is the same as power series and a mix of ratio tests. And I'm gonna explain it to the best of my ability. And let's get started. So here we have a problem, right? And when you're given a question about trying to find the representation of a power series, it's gonna ask you to determine the interval of convergence and find a power series representation for the function right here. So our first step is just to rewrite this right as a series, right? Or like how the power series is. So we can rewrite this as series infinity n equals 0, right? And when you see this, right, it's always gonna give you like a denominator because the representation of functions for power series it's just always gonna give you right. And the main thing you gotta focus is this part. See where I'm like hovering around? You gotta focus on the x squared. It has to be minus. And because you gotta have to put something here, right? So we have to rewrite this right as a series, right? To make it like fancy, right? But we have to put this into here, right? Because the basic standard of what you gotta do, right? Is you gotta like rewrite this, right? To make it look like this, and you have x to the power of n, right? So basically we gotta this x is basically this x squared, right? So like if I'm circling this, right? This is going to be inside here. And the cn you can like forget about it. I think it's just there because they want to like confuse you all, I don't know. But yeah, so you gotta like put this in here. And yeah, so oh yeah, you always gotta put in an n, right? Because that's the basic like standard here. So when it's negative, like if it's like 1 minus x squared, you don't have to put negative because if it's negative, then you're chilling because it's you don't need to put nothing else. So this would be x squared, right? And if we like distribute this would be the same series, and we can distribute the n. So this would be x to the power of 2n, right? So this is like the power series representation of what you need to know. And our next step is to find the radius convergence, right? Because we all got to do that. So just to find the radius convergence, it would just be we got to do the absolute value of x to the power of 2 that is less than 1, and we can we have to be left with x, right? So we have to what can what method that eliminates the squared, right? We can square root it, right? So it'll be just like that, and we're left with x is less than 1. And the final here is going to be the radius, right? So this will be radius of convergence is equal to 1, right? And our interval convergence, well, let's just put in for our interval convergence, we could put in whatever number that would be equal to 1. So if we put in -1, right? So -1 absolute value is 1, right? And squared is 1. So we could put a -1. And if we put a 1, it's obviously going to be 1. So our interval convergence is going to be -1 and 1. So that's pretty much the basics of what you need to know for this concept. Right, here we got another question, right? And it looks kind of different than the last one. So here we got fx equals 4 over 2x plus 3. And we need to make this function equal to like 1 over, let's say, 1 minus the x, right? So what we got to do is take out the 4, right? So the fx will be, let's say, take out the 4, and we got 1, right? because we don't need the 4 in this problem. So we got 2x plus 3, and we can eliminate that. And the x has to be in this slot, and the 3 has to be here because it will make sense more. So this would be just, we could just switch the numbers around so it won't be a big problem. So this would be like that. And the x always has to be in like the left or the right, the bottom right. So now we gotta take out more stuff out, like out of the function, right? So what can we take out that can be, make it look good, right? So we can take out 1 over 3 because we got 3 over here. So we got 4 right here, and we got 1 over 3. So that won't affect the 1. This will affect the 3. So take out the 3, will be left with 1. And this will be equal to 2x over 3. Because if you multiply, when we take out the 1 over 3, right? And if we multiply 1 over 3 back, it will be, the 3 will cancel out. Because the 3 will times the 2x. And if you divide it by 3, it would just leave with 2x. So we would just be left with that. So now we can like multiply this together. 2x over 3. Now we gotta make this subtraction, right? Or minus. So we got 4 over 3, 1 over 1. So since we have a positive, right? We have to make it somehow negative, but it will still equal to positive. And to do that, we can do two negatives, right? So this is two negatives because a negative times a negative is positive, but we're trying to make it, we have to make it negative because that's how the representation of functions for power series works. So yeah, we gotta do that. Just make a negative. And now we're finished and we got our x over here. So on to like the next step. So our series is just to the infinity, n equals 0, and we can take out the 4 over 3 and we can take it out, the series, and we could put in negative 2x or whatever's associated with the x into the slot. And in this case it's negative because we changed it to a negative, so it has to be negative. And like the previous question, it was already negative, so we don't have to put in a negative there. So now we got to put an n, and this changes to 4 over 3. We got our series. And if you have a negative, right, we can take out the negative and we can distribute the n because technically the negative 1 is still has the exponent of n, so we can just take it out. And we're left with 2x over 3 n, and the distribute is 2 to the power of n times x to the power of n and 3 to the power of n. And I'm only talking about this, like this part into here. And now our third step is to find the radius of convergence, right? So here we got negative 2x over 3, right? So we gotta take the absolute value, right? So we were left with negative 2x and 3. And it has to be less than 1 because that's how you do the radius of convergence. And now we have to redefine this, and we got 2x over 3 less than 1. Now we have to take out all this stuff so it makes it look fancy. So we got 2x, take out the 3 or multiply the 3 by each side, and this would be just 3. We can divide it by 2, and this would be 3 over 2. So our final answer here is the radius of convergence. So the radius of convergence is 3 over 2. And the final step is the interval of convergence. So the interval convergence is basically the opposite of this, so it's going to be negative 3 over 2 and positive 3 over 2. Because when we plug in negative 3 over 2 here, or negative 3 over 2, it's going to be equal to 1 because when we plug in negative 3 over 2 here, it's going to be equal to 1 because the absolute value will already make it to 1. And if we plug in 3 over 2 again, it's going to be equal to 1. So, or if you want to think about it an easy way, when you have the radius of convergence, the interval convergence will be a negative of that and a positive of that number. So that's kind of the easy way of how I like to define the interval convergence. But yeah, this is basically what you need to know for this topic. And that's pretty much it.